Hi. Started?
What? Are we live?
I hope so.
Are we on the internet?
We'll find out.
All right, cool. Hey, this is Sam from Independent Security Evaluators. And with me today is Ian Sinderman. Independent Security Evaluators is a company that does security assessments, software, hardware, anything. Clients engage us, and we work with them to find vulnerabilities, write up reports, and help them remediate those problems. Right? Cool. So today we're going to be looking at a device as part of our series called ISE Labs, where we are researching a bunch of devices in the embedded electronics space.
Primarily small office, home office, that sort of thing.
Yeah, it's a big extension of what we did back in 2013. So Hopelessly Broken. It spawned into a contest. That research turned into a contest that you might have played at IoT Village. We're at IoT Village. We're running that contest. You get to see some of the research we did as a form of educational contest and that. So today, what are we looking at? What are we going to be hacking today?
So we're going to be hacking the Buffalo TeraMaster model number in the title. It's so long, dude. So it's this fairly large business-oriented NAS device. I guess aimed more towards like small businesses, large photographers, that sort of thing. I think it costs nearly $3,000.
So it costs a lot of money.
Oh,
I mean, it's maybe targeted for a more professional type person.
Definitely.
I've definitely seen it being sold on B&H, which is a photography website. So people who deal with film, deal with photos, definitely use this device.
Yep. So with this device, it's going to be storing photos, business critical assets, maybe even tax documents. So with the vulnerabilities that we found, we get all that.
Okay, cool.
So yeah, we get our little hacker fingers in there and get those sensitive documents, as well as anything else we'd like.
All right, cool. So as the vulnerabilities we're going to go over today, like the methodologies, everything like that, is it step by step? What are we seeing today?
Pretty step by step. We're just going to start out with some of the basics of how we got acquainted with the device, how we gathered information, started looking at files, how we got files, and how we went through those files, found vulnerabilities, and exploited them.
All right, cool. So hopefully everyone at home should be able to take notes, sort of see, what it takes to actually hack something, actually do some research on one of these devices. I think another cool thing is, are these vulnerabilities going to culminate in an exploit that gives us total like a root shell? Something all right. Yep. So once you have this exploit, you have full control over this computer on someone's network.
Yep, you have control of everything that device does, everything that it interacts with, all of its functions.
All right, cool. Well, is there anything else you want to say before we get started?
Not that I can think of.
All right. Well, I'm going to be back there manning the computer. If anyone has questions, I'll make sure to bring them up in the chat for Ian to answer. Also, if you're watching this after we filmed it live, you can contact us on Twitter. So make sure to look in the description below and smash that like button and do all that other stuff.
Totally.
Interact with us online. We'll answer your questions. You'll be able to find us. Also, all of our blogs, all of the things we're doing have blogs associated with them. So make sure to go check out the blogs. You can see the different CVEs that we're getting associated with these vulnerabilities. So we're all over the place. I think it's a good deal.
And there are much more vulnerabilities that won't be covered in this live stream. There are tons of vulnerabilities for this device. I'm only going to cover like because we only have so much time.
All right, cool.
So check out the blog. There's a lot more there.
All right, cool. All right, awesome. Get out of the way.
All right. So I guess one of the fun things about this device was that when we initially started looking at it, we encountered a problem before we could even start testing. And that was that we had forgotten the key for the front door. Or the front door of the NAS. It has this beefy little lock on it. So we needed to get rid of that. So everything in this door has a function. It's built for a purpose. The door allows you to control access, whether you can come in or you cannot. The lock is the authentication mechanism for that door, and the hinge allows the door to actually do its movement. So all of those do their job quite well. But the lock was causing a problem. So all we had to do was give the lock just a little helping hand, and then it could do its job just a little more better. By which we mean we used the hinge to just bypass the lock by popping the hinge open. That kind of set the theme for this device. We found a good number of vulnerabilities that exploit or that exhibit similar things, where a function is doing its job perfectly fine. It just happens that if we give it a helping hand, it does its job a little better than it's supposed to. So I guess let's get right to it. So first things first, if this was a brand new device that we had never looked at before, we need to get a feel for what we're actually looking at. So if we can switch over my screen, first thing that I always like to do is just Nmap the thing. Nmap is used for a surprisingly large number of things, but most people just use it for port scanning. And we do something like Nmap tac A, which is kind of like a macro that just enables common functions or common flags for Nmap, such as service discovery, common ports, that sort of thing. You can do tac, which specifies scan all ports, TCP case. And something like tac OA, file name to log it to a file name, and then the IP address of the device. We're not going to do that right now because it takes a little while, so I have one prepared already. It would look something like this, although admittedly we would not have telnet open. That is not relevant. But we do have something like web server. We also have SMB, HTTPS for web server, more SMB, printer, Apple File Protocol, all sorts of attack surface that we work with. Was rsync, another HTTP server, and two unknown services. So web stuff is kind of my bread and butter, so that's what I'm going to dive into. So we know there's a web server, so we can just go to it. In this case, there is a fairly nice administrative interface. You log in, admin credentials, and then using something like Burp Suite, which is kind of a proxy that you tie into your browser, we can intercept all of those requests, see them in great detail, search through them, and if we would like, we can start modifying them. So, but for this information gathering phase, I'm not going to really modify anything. I would just go through everything I can, flip every switch, push every button, change everything I can, just to generate all the requests that I possibly can, so that I can search through it later, figure out how the device is working, and find any juicy. Again, I'm not going to do that right now because that takes like hours. Tons of functionality here. But one thing that I can say is that going through all these, we did not really find anything to enable remote access or like remote shell access. A lot of NAS devices do allow that. You can enable SSH and log in as root or administrative user. Not so much here, so that makes testing a little more difficult. One of my colleagues did find a utility online that allows you to kind of enable SSH, called ACP Commander. Sometimes tools like that exist, sometimes they don't. I couldn't get it to work, so I took a different route. Another really great resource online is stuff like firmware. Sometimes it's a little harder to deal with, but tools like binwalk can help with that. In this case, we don't even have to worry about that. We see in the firmware, it's just a zip file. So if we unzip it, a while, see HD rootfs, that sounds quite nice. CD in there, see. You can see hdrootfs.img. Oftentimes these are like raw image files. In this case, not so much. We can use the Linux file command to check the magic bits, since it actually is. Get a general idea. We can see it's a zip archive, range extension. But if I unzip it, apparently it's encrypted. So that's a problem. Now we could try and find whatever update mechanism is being used and try and reverse engineer that, for all that rigmarole, but we could also just Google it and find out that some really smart people already did that and published their stuff. Look at asked some very smart people at NAS Central, first engineered it already. I think NAS Central is kind of dead now, but we still have the info. We have the encryption key. If we just give that encryption key, it'll start unzipping our firmware file. It takes a little while, not too long though. So now I'm going to change directories because I happen to know that this gets a little. So we run file on the new file, firmware, bs.buffalo.updated. We'll see that it is a zipped compressed data file, so it's probably a tar.gz with compressed tarball. So let's try and unzip that, or untar that. Tar extract file. Hope that it works. Get a ton of errors, but that's kind of a good thing because we don't really want tar to be making all these nodes. So we can safely ignore this. And now we see we have a whole bunch of files to work with. So although we don't have shell access to the device itself, we can see probably most of the files that it's actually. So what do we want to do with that? Well, we want to find the juicy bits. So if we're looking around at the web application, look at requests that it's making, we can see that, you know, a lot of it seems to be done through NAS API. Little path here. It appears to be a JSON API. So, you know, you send your JSON payload and it replies with another JSON payload. We can also see in the headers that the server is WSGI and it's running Python 2.7.9. So now that we have the files, Python, there's a very good chance that we can just read the source code, because that's how Python works. So that is something that I'd very much like to find. But while we're looking at these requests, we can kind of get an idea for how everything works. You can see that in all these requests to NAS API, a little bit, we can see that there's a method down here, and that method changes depending on what you're actually doing with the API. So instead of something in the path, it's something in the JSON body. There's params, which can change depending on endpoint. So that's probably arguments for whatever function it is. We also see SID parameter with a lot of these. Now that is our authentication token. You can also see that some endpoints don't need it, some do. So they're going to have some method of saying this is a authenticated endpoint and this is a anonymous endpoint. So knowing all of that, we want to try and find the source files behind all of this. So I think I'm just going to take method here and just run a recursive grep. So grep is going to look for basically files containing the string that we give it. So the assumption is that if the API can call this endpoint, that endpoint probably has to be a string somewhere in the Python files. So if we just run recursive search, it should find file. We see that it finds a lot of JavaScript, but down at the very bottom, see user local lib NAS API modules generic.pyc. Pyc is something worth noting. cd into that directory and see what we have to work with. NAS API, ls. We'll see that everything is .pyc. Now, if you've worked with Python before, you've probably seen these get generated after you run a normal Python script. This is kind of Python's way of optimizing things, if I recall correctly, because it's kind of like a pre-compiled Python script. It also means that if we try and just edit it and look at it like a normal Python script, it's a little on the ugly side, because it's all compiled. Well, mostly compiled. However, with Python, pretty easy to decompile it. I'm going to use the utility called uncompile6, which is purpose-built for this. Let's look at the flags that we can use. Most of the flags. all the ones I'm going to use don't show up, but take my word for it. We're going to use tac R for recursive to go through all of the directories in this subdirectory, tac O to output in this current directory, and then we're going to also search through this current directory. So we're going to let that run. It's probably going to take a little while, and it may encounter some errors, but for the most part, it's going to get everything. So once all of these files are decompiled, we can start searching through them manually. We can also use tools like Bandit, which is kind of an automated tool for looking for vulnerabilities in Python files. I prefer to go through manually if I can, because I tend to find a lot more stuff than Bandit will find. It tries, but it's not quite that good. So once this finishes, normally during an assessment, I would just look around and get a feel for how the application works. Not necessarily looking for vulnerabilities, just trying to understand how it works. And in doing so, I will have noted that Buffalo RPC2.json handles a lot of authentication. NAS API ID happens to be the main one. We also have all of our modules in here, and they are loaded by NAS API ID, that sort of stuff. So now that we have a general feel for how it works, we have some files to look at. Start crawling through them. Let's look for some juicy functionality, such as authentication workflows. So if we've gone through before, we know that Buffalo JSON RPC2.py handles a lot of authentication stuff. We can take a look at that. So we see a lot of imports. It imports OS, which is interesting, and Subprocess, so it could be doing some dangerous stuff with command lines. Also see some static variables, that sort of stuff. Almost immediately, we see some very interesting strings, such as skip auth. Yes, please, I very much like to skip auth. So it doesn't seem to do a lot here. You see that they seem to be checking auth-free underscore APIs, so maybe that's what they're using to configure, is this an anonymous API endpoint or is this authenticated? But that warrants further investigation. So if we look around for skip auth again, immediately we come to something quite interesting and quite fun. So I see that in this big function here, that is kind of the first thing that a request hits after the Python server receives it, and it receives this from a CGI base. So the first thing it does is checks for all the errors, and then it tries to make sure that there's actually content to load, and then it tries to load the JSON, and then it does something rather interesting. It checks the HTTP host environment variable, and if it's localhost, it simply says, skip auth true. It's okay, we can let this go without checking authentication. So HTTP host is probably simply the HTTP host header after it has been turned into an environment variable by the CGI interface and passed to this script. So the HTTP host, why would they be checking if that's a local host? It kind of makes sense in some ways. If you think that if this is the main API endpoint for this entire device, there's going to be loads of different systems and scripts on the device that may need to interact with it. And dealing with normal authentication in that case is cumbersome. At least it can be. So what if you just make it so that any calls from inside the house are presumed to be safe? It works in many cases. And think about it. If you make a request to localhost, HTTP host is always going to be localhost. The only issue here is that, I'm sure many of you have already figured out, the client controls the HTTP host header. So I can just say that I'm connecting to localhost. The server accepts it, presumably, just going by the code. It's not good. So let's see if that's actually how this is working. So if we go back to Burp Suite, find one that is fun to play with. Sure. Network.interface list interface settings. We send that to repeater. We can then try and poke around with the authentication. So currently it has a authentication token. I think it's expired. It has, so we'll grab a new one from here. Grab this. Replace this auth token, give it another shot, and it is still invalid. Or even farther up. Well, I suppose it doesn't really matter because we're trying to bypass this anyway. So what we want to do is set our host header to be localhost, because again, it's checking the host header. If it's localhost, it will say that we can bypass authentication. 7.0.1. We'll try again, and we see that we do get a different error. It's not great, but it is different, which is very important. You can see that it's saying list interface settings takes no arguments, but we did give it one. The only parameters that we sent were our authentication token. So if it's skipping authentication, it doesn't really need the authentication token, right? So what if we just delete it? Well, there's our data. Admittedly, we do still have our authentication token as a cookie, but what if we delete that too? There's also our data. That's not good. Essentially, this means that if we just set our host header to localhost, we can administrate the entire device. Now, this isn't something like a root shell. We still can't enable anything like that. But it's not good. Like, I can change root passwords, change file system settings, just give myself access to everything. Not good. But we want to take this further, don't we? So let's do that. So we've gone through one juice a little bit. Let's look for another juicy bit. So authentication, let's just ignore that for now and start looking at any dangerous functions. So we saw OS and subprocess earlier. See if there's anything that uses those to do anything fun. So let's see, I think a good file for this would modules network. You figure interacting with the network, it's probably going to run a lot of commands, stuff like working with interfaces, all sorts of random settings. Who knows? Let's take a look and find out. So straight off the bat, let's start looking for anything that uses subprocess. Because if it's making any calls to the command line, like here, it's essentially running a system command that is ifconfig with this input, which is whatever got passed to this function, and then piping it into grep for mask. Now, if we can control ifname and it's not getting sanitized, then we can control the command that's being executed, and since they set shell to true, we can run whatever we like. Now, I don't quite remember if this function is vulnerable or not, but in a normal assessment, I'd follow it up, work my way up the call stack, and find out where ifname comes from. But I think that one was not vulnerable, so we'll just keep moving on. See ones like this, where it has command line, but command line is static. There is a lot of these in this file. We can, for the most part, safely ignore those because it is a static string. We can't get user input into it anywhere. Keep moving down, still static strings. There is a lot. But eventually, we will come to, I think it's set. Sorry, this file is massive, so let me find this function. Set domain function. It again calls subprocess. It still has shell set to true, so any shell meta characters that we put in there, like backticks or semicolons, ampersands, all that good stuff, will be interpreted. And we see that it takes join command, user password, and RPC old. RPC old join and join CMD seem to be static, but user password does not. If we follow, just work our way up the program, we can see that user password is built from the username and password values, which were passed to the function. So let's keep working our way up, just like we would for anything else. See what calls this function. Down here. So this function is passing admin username and admin password as username and password. Let's see where those came from. Just have to slowly work our way up the functions, look for anywhere that it might be being sanitized, or being set, or constructed. Working our way up, we can see a few places where they're just doing sanity checks, see if it's blank or not. On working up, eventually find out that it just comes from that function. Like, that function is called with admin password and admin username, and the function just gives it to the next one. Now this function, that's an API endpoint. So theoretically, we can just call it directly and supply something nefarious for admin username and admin password. Give it a shot. Now, we could just construct a raw query for all of this, but that's a lot of values that I don't want to deal with. So instead, what I'm going to do is go into the web panel, try and figure out, it should be in networking because that's the file we're in, ideally. Work group domain sounds about right. That will explain why the session didn't work. Super secure password to log back in. Edit these settings because I think this is going to interact with the function I'm interested in. Next, just going to add some random values for this because we don't expect it to work. We just want some requests that we can work with. Yes, host. So we'll send off that request. Probably going to error out, but if we go back into Burp Suite, we should see request, network set auth settings. We have that full request already built out for us, so we don't have to worry about constructing it. If we send it to repeater, we can start doing our various deeds. So we know that admin username and admin password are expected to be passed down to another function that simply adds them to a command line and executes it. So hopefully, add some shell meta characters in there, execute. So I'm going to use a backtick to a pair of backticks to open a subshell. And I'm going to run D, which simply will open a telnet server. I'm going to do tac l/bin/bash, which sets the login shell to bin bash, which effectively bypasses all password checks, which is quite nice. I'm also going to set the port to 8000. And then the final backtick to close off the subshell, and we'll just run it and see what happens. Well, ideally, we'll have a bind shell on port 8000 after this. So we should expect the API to give us an error after this because we have given it some very strange input. But even if that does happen, AnyLog, our command, will have executed. Matter of waiting for it to return. We do see we did get an error. Got a shell. So I'm going to telnet address 4, and then the port was 8000. 1.4. It was a shell with a wonderful crunch, which means, so now we have a root shell, which means we can do whatever we want. We have root access, we can see all your files, change all your settings, or just destroy the thing. What's even better is that, although this did require authentication, we can just remove the SID and set the host to localhost and use our good old off bypass vulnerability and do this without knowing the user, the admin's password. That's much more like it. So now that we have root, it's kind of game over. But there is one more vulnerability. At this point, we found root command injection in so many of these devices that it's kind of not fun. So I'm going to go for a fun vulnerability. Fun in my opinion. So while we were looking at that other file, you may have noticed that there wasn't really anything that said whether or not that function was an API endpoint. So oftentimes in Python, they'll use something like decorator, which is @ and then function that will be that will decorate the function below it or the object below it, and that can be used to set up what is and is not an API endpoint, what permissions, flags, all that good stuff. Other times they'll have a list of configured API endpoints as an either, which is odd. So how are they doing that? how are they constructing their API? So we go back to the Python files, we can take a look at the main Python file, which is NAS APID. We can see a bunch of common stuff. But what's interesting to me is that we start seeing stuff where it's loading the API endpoints. You can see here that if there's an underscore in the API endpoint or the method name, it will remove the underscore, which we did see in the requests. Eventually work our way down and find out where this program is loading in API endpoint, which is around here-ish. So first it looks for module generic because it loads them differently. We'll skip over that for now. We'll look for public APIs, extra arg UID APIs. Eventually it will get to here. So in this big old line of messiness, we can see that it basically goes through the module that it just imported, which would be networking.py. It goes over all of the objects in that Python file, and if it does not start with an underscore, and it is callable, boom, it's a function, or it's an API endpoint. Simple as that. I guess this was designed so that it makes it very easy to write these programs, because normally you have a function that isn't supposed to be used outside of that Python file. You just prefix it with an underscore as a matter of neatness. Here they've used that matter of neatness for configuring their API. Now this does work quite well. It makes it very easy to build out the API. It makes it quite quick and simple. However, it again does its job slightly too well. Because if we go back to a different file, such as, let's see, wbfs.py. So this file, we can see that normally we have our functions, because this would be a API endpoint and this would not. However, the way that Python works is that the functions and objects immediately written in this file may not be the only ones there. We go up to the imports, it's importing OS. So within this file, you'd have wbfs.os.whatever OS has to offer. OS itself is not callable, so it would not be a API endpoint. Then we get into stuff like this. From settings, import star. If there's anything in settings that does not start with an underscore and is callable, suddenly it's an API endpoint in wbfs. Same with confutil. So if we look at those files, such as confutil, you can see right off the bat, the first function in here, not prefixed with an underscore, looks pretty callable. So there's a pretty good chance that within wbfs, you can just run readconf. That's not too severe. It lets us read shell-style config files. Write-conf is a little worse, though, because we can probably just write configs wherever we want. So let's find out. So I'm going to take this old request, send it to repeater again. I'm also off bypass, so I don't have to worry about the authentication stuff. So I'm going to set the method to wbfs, because that is the file that we were working in, and wbfs.conf, because it strips out underscores. And in params, I think it just requires path. Path and optionally remove quotes, just apply a path. So we need to find some file that has equal signs between the values and keys. How about //.conf? Give that a shot. Even if the path isn't there, the API will tell us whether or not the API endpoint exists. because it does have different errors depending on whether or not API endpoint simply doesn't exist or if it was given a incorrect value. And we see that I screwed something up because we got 400 because I missed a period. There we go. Well, that apparently I got the path right because now we have the contents of etc rsync.conf. So effectively, we've just used an API endpoint that nobody wrote. And we also have an API endpoint that nobody wrote that can do a lot more dangerous stuff. We have write-conf, but writes a config. Let's try doing that. Write-conf, let's give a path of, I don't know, /tmp/fork, or fork.txt. And we're going to need, so it looks like it needs data, and within that data, it's going to be looking for an array. I think that's a, oh no. So set up some data, and we'll just try the value, see if that works. Could fail horribly, or it could apparently work. So now that we have a shell, we can see if that file actually was generated. Fork.txt is in temp, and it does have key equals value. So that's neat, but what can we do with it? Well, what if we can write shell scripts? Try that. Shell script. Try comment, the first part, and maybe a new line to get away from that, and telnet d tag l/bin/bash tag p a3a3. See what that looks like. We cat that file. It does look like a shell script that should execute just fine, except I forgot quotes. That is an option we can specify, but if we look at the permissions for this file, we will see that it is not executable. So it would be nice if we could just like overwrite an init script that would give us a shell on boot, but we can't because it would be not executable and it would fail to execute. However, there are other files that we can play with, such as config files. Now, most of these are going to be fairly benign. Maybe we can break a service, but we probably can't get man injection. Except for stuff like cron. Now cron is very fun. Essentially, cron tab, cron, lets you schedule tasks or commands that you want to run at a certain interval, like every 10 minutes, every hour, on certain, this minute of this hour of this day of the week, that sort of thing. Root already has one. Runs a whole bunch of different things, including some things that I have to remove. Spoilers. But essentially, yeah, we can just overwrite root's cron tab and then make a shell spawn every minute. That sounds pretty nice, right? So that's a bit of a pain in the butt to write out. So I'm just going to use one that I already wrote and explain what it's doing. So again, we're using wbfs.writeconf, which is our wonderful API endpoint that nobody wrote. As an API endpoint, set our path to etc cron tabs root cron file. We set the value to be a comment, and then the data is a new line, and the existing cron tab, so the service can still run as normal. And then at the very end, we have another new line, and then tell it to start telnet d on like every minute. Just give us a new telnet d instance if it's not already there. And add quotes false so it doesn't add quotes that break them. So if we send this, it will overwrite root's cron tab and look exactly like the one that I showed initially. I forgot to delete that line, but it should be good to go. There is one catch though. Since we've not modified this normally, cron tab does not know that the file has changed. So cron tabs are just going to go with the one that it has in memory and not do anything. You could probably just restart it or send a sig up to the service, but assuming we didn't have a shell, we can't really do that. We can just reboot the device though, so we can just do that, and it'll beep, and eventually it'll come back online, and once it's finished booting, it will just give us a shell every minute, on the minute. But that takes a while, so call it there. So yeah, I hope you found that somewhat interesting, and I hope that this kind of showed that it's very helpful to understand how these functions work, to dig into them and find that, you don't just have to throw command injection attacks around to find fun vulnerabilities. I love command injection as much as anyone else, perhaps more, but the satisfaction of finding such strange things as, an API endpoint that nobody wrote as an API endpoint, and getting shells on the minute by the minute, quite nice, and I highly recommend it. Although it seemed like we breezed through this quite quickly, this is a culmination of days of work from multiple people. So if it takes you a little while, don't worry, it takes me a long time too. So yeah. Anything? All good to go?
On it for the day?
Sure.
Alright, cool. Well, I hope everyone enjoyed that. We should be back with another live stream when, in the next couple weeks or so?
Should be. I think it's either next week or the week after. I'm not entirely sure though.
Alright, cool. But we're gonna have more vlogs coming out. We should have one coming out in the next couple weeks.
Mm-hmm.
We are sort of wrapping up this entire project soon. I think if you haven't seen any of our previous work, make sure to go back and check out our old videos and check out the old blogs. Give us your feedback. We'd really like to know how you think live streaming format works out for you guys. We want to know if you want to see other types of live streaming content. If you have anything at all that you want to send to us, send it to us.
Yeah, sure.
But yeah, we're just really eager in finding out how we can better work with the community, people out there who are interested in learning this stuff, people who maybe don't have all of those same resources we have. We can sort of point you in the right direction.
Mm-hmm.
With that, just always want to encourage you guys to make sure to follow us on the internet, on Twitter. Make sure to come out and see us at our different events. The next event that ISE people are going to be at will be Hack in the Box Dubai, which is going to be the 25th or something of this November.
Like that.
Yeah, so make sure to go say hi to Lisa Green, Jake Holcomb, Drew Branch, Edith Whitney. All those good people from Independent Security Evaluators will be there, and you actually get to play with some of the devices that we've done research on and try to reproduce the vulnerabilities and sort of learn those systems yourself. So you get some hands-on stuff. So anyone else going to Hack in the Box, make sure to come see us. All right. Good?
Hope so.
All right. I know we liked it, but you loved it.